Complete tutorials on CAN protocol, CAN part 2 and CAN introduction. Here we starts with the CAN bus history. The first idea behind the CAN protocol was first conceived by the engineers at Robert Bosch, Germany in the early 1980s. The early focus was develop a communication system between number of ECUs because when after 1980s most of the cars comes with ECUs, so it's rather the number of ECUs, but of course ECUs is a ECU. So the protocols whatever have been used in a conventional method, so it's not so efficient. Hence the Robert Bosch engineers brought this concept called CAN protocol. The new standard, it is none of the communication protocol at the time met the specific requirements for the speed and reliability. So the engineers developed their own standard. Even now, no standards has been beaten this CAN protocol. Yes, of course, FlexRay and some other protocols has come up, but the reliability as well as the economic has still the CAN bus is not beaten one. So the development of CAN. The development of CAN began with the more electronic device were implemented in the modern motor vehicles. That is the advanced vehicles have been used the CAN protocol, but nowadays even the mid variant vehicles are start to use this CAN protocol. The examples of such devices include the engine management systems, active suspension, ABS, ESP, gear control, lightning control, ACs, airbags, and central locking system. These are all the components at the system level have been used for the CAN communication as a protocol. All this means more safety and more comfort for the driver, and of course the reduction of fuel consumption and exhaust emission also reduced. So obviously the efficiency goes so high. Hence the CAN has marked its own standard so that it brought into the market. To improve the behavior of this vehicle even further, it was necessary for the different control systems such as the exchange of information among the sensors. Say for example, if we have many sensors, the exchange of information between these sensors have been more reliable after the CAN existence. This was usually done by discrete interconnection of different systems, that is point to point wiring. The requirement of the information exchange has been grown such that is of course the CAN after the CAN protocol have been launched in the market, the information exchange have been more simpler and easier to make the engineers to design as well as the convenient for the users or the customers for their usage. Here the quick timeline for your understanding. 1983, the first CAN bus project at Robert Bosch. 1986, the CAN protocol introduced. So before introducing, they have just done with their in-house project. After it was been successfully satisfied and they have proven it will increase the efficiency. It has been launched in 1986. Then in 1987, the first CAN controller chips have been sold in the market. Then 1991, CAN 2.0A specification published. 1992, Mercedes-Benz used CAN network. 1993, the ISO 11898 standard. They have been made their own protocol. Then 1995, ISO 11898 amendment. So it has been the law has been passed to use globally. So present the majority of the vehicles use this CAN bus. So this is how the CAN evolution have been launched and it's entered into the market. So CAN bus overview. The physical layer uses differential transmission as a twisted pair wire. So you can just imagine how the twisted pair wire will be. The same CAN protocol has been used. The buses uses NRZ, that is non-return to zero, with the bit stuffing. The nodes are interconnected to the CAN bus is wired and the fashion, that is the wired function has been the one node is driving the bus to the logical zero, then the whole bus is that the state regardless to the number of nodes transmitting in a logical way. Maximum rate of 1000 kilobits, that is 1 mbps, 1024 kb per second at maximum bus length of 40 meters or 130 feet when using the twisted wire pair, which is the most common bus medium used for the CAN communication. So hence it's a 1000 kb. It's approximately they have given but it's 1024 kb. The message length is short with a maximum number of 8 data bytes per second, and there will be low latency between the transmission request and start of transmission. So here the SOF frame starts. The message are protected by the CRC type checksum. So these are all the some of the significance where the CAN bus really proven its efficiency in this market. The bus access is handled via advanced serial communication protocol, that is carrier sense multiple access and collision detection with the non-destructive arbitration. So as arbitration we'll see later, and this is a CSMDA concept. This means the collision of the message is avoided by bitwise arbitration without loss of time. So here there will be loss of time and there will be loss of data, whereas compared to the conventional protocols at that time, so they have a huge disadvantage with the loss of time as well as the data. So this can be it's just compensated by the CAN protocol. There is no explicit address in the message. Instead, each message carries a numeric value. So here, the all the message carries a numeric value. So the priority on the bus makes so simpler in CAN. So it may also serve a identification of contents of the message. So in terms of the message ID, so these things we'll see in the upcoming slides. So here just you want to know the understanding of the how CAN bus is introduced into the market. So it's from the scratch, and highest baud rate is 1 mbps, that's what we have seen. And CAN uses a message oriented transmission protocol. So it CAN is a message oriented protocol that you have to be aware. Then there is no defined address, just a defined messages. So here the message ID has been defined and no address ID. Controller, that is CAN protocol is a serial bus system used to communicate between several embedded 8-bit and 16-bit microcontrollers. It was originally designed for use in the automotive industry, but due to this because of the efficiency it have been proven, it has been used for many other industrial purposes as well as the home appliances. An elaborate error handling scheme that results in retransmitting message when they are not properly received. So this is also one of the main feature of the CAN, so error handling. So it will keep on say, for example, if I am transmitting you some data, you are trying to receive, if there is any blockers, then the CAN protocol detects that and it will again send you the same message until you receive successfully. So that is one of the main significance and uniqueness of the CAN protocol on error handling. There are five effective means of isolating faults and removing fault nodes from the bus. So we have the its effective means. For example, say if there is a fault occur, so CAN protocol tries to auto diagnose and it will try to auto repair by its own protocol set of rules. So this is one of the another significance in CAN protocol. CAN bus or the controller area network bus. An automotive serial bus system developed to satisfy these are all the following requirements: network multiple microcontrollers with one pair of wires. Yes, we can connect n number of nodes with the pair of wires, one pair of wires. Allows the microcontrollers communicate with each other. It's a high speed and real time communication. It provides a noise immunity in electrical noisy environment with very low cost. Again, we have what is CAN. So it's a two-wire bidirectional serial bus communication method, and it's originally developed in mid 1980 by Bosch for automotive use. So the main design objective is economical solution. This is one of the major significance. It's economical solution for implementing the high integrity networking and real-time control applications. And now we have the standardized internationally. They have been launched. It's a 2.0a and 2.0b. It is ISO 11519 is a low speed CAN, and ISO 11898 is a high speed CAN, and the CAN validation is ISO 16845. So these are the documents also you can refer, and we will just give you the points by extracting some of the contents concepts from these ISOs. Usage exceeds, that is this number of nodes can be, it's around 2 lakhs 20 lakhs nodes in 2001, still growing at 30% rate annually. make many current and potential non-automated application opportunities. So these are all the exceeded limits. So it's just for a knowledge purpose, but in automotive it's not, they are not using these many nodes. Then the main significance of this CAN protocol, one is the reliability. It's an error-free communication. If there is error also, it will do self-diagnose and it will repair itself. Then economy, of course, the wiring cost is low and hardware cost is also very low. Then scalability, it's a easily expandable and it's a low node connection cost. Yes, of course. The availability is more chips with CAN hardware, the more off the shelf tools, then higher level protocols. Then the popularity is knowledge based expanding, so it's keep on expanding, and most of the automotives prefers CAN protocol. So the specification, yes, these are the specification, and we have seen it's uh, this is what, so 2 CAN 2.0 a is 125 kbps, that is up to 500 meter, and CAN 2b is 1 mbps up to 40 meter. Then you can also transmit more than 40 meter, we'll see in the next upcoming tutorials. But if we increasing this length, then the speed will decrease. It is suitable for the difficult environment, industrial, automotive, and more even the home appliances also. The reliability requirements is, it's a integrated error detection and confinement. It's a automatic retransmission of the corrupted message. That's what I said, it will self-diagnose and it will repair the corrupted messages. And the probability of the undetected bad message is less than 4.7 into 10 to the minus 11. This is what the accuracy have been given, so it make the CAN protocols are reliable. The number of nodes, it depends on the physical layer, that is it's greater than 100 is feasible. Number of masters, every node can initiate communication and negotiate for the bus, hence every node masters every node acts as a master. Then net data transfer rate, it's up to 577 kbps net at 1 mbps total data transfer rate. So the message priorities, message with the lowest numerical value id wins. With that we'll see the arbitration process, but as of now the message priority is a arbitration process. The id with lowest value always wins the bus. See here they have given node A, node B, node C, D, E, and node X. So this is how the CAN protocol works. So this is the data, the transmission reception of data. It will transmit from here to here, where it depends. So this is how the structure. So we'll see again more in the upcoming slides. So here CAN in market. It designed specifically for the automotive application, and today industrial and medical equipments also have exist with the CAN protocol. So here the 80% is used by the automotive, and around 20% has been used by the other, so medical industry as well as the home applications. So before the CAN has been launched, how it is. So these are all the number of modules in the car: AC, power windows, airbag, power locks, power seats, lightning, dashboard. See, power seats, power locks. So these are all the somewhat high-end cars. Anti-lock brakes, active suspension, engine control, transmission control. So the wires are so clumsy, and so the arc structure also so complex. If any damages or repairs happen, it's very hard to even debug. So also not only the it depends, it not only it matters with the physical, also it matters with the transmission of data, the efficiency. There's a loss of time, there's a loss of data, there'll be corrupted message. If the message corrupts, it's very hard to diagnose. Everything has the more and more drawbacks has been introduced when the exist when the ECUs has been introduced with the conventional protocol. To just overcome these drawbacks, the CAN has comes into the picture. So here see how simple the structure is. If any problem, you can easily diagnose, you can easily understand, and moreover CAN itself can able to diagnose and repair its own fault. So this is how the CAN protocol, and this is how the simple architecture as well as the simple structure has brought into, which impress everybody into the automotive industry. Hence it really popularized in a very short span of time. So yes, we have done with the CAN 2, and we'll continue with the complete tutorials on CAN protocol in the part 3. Here we will discuss with OSI layers and ISO standards with regards with the CAN protocol. So the main intention of these this tutorial is to you have to get from the knowledge from the scratch till the end. That is what the main intention. So requesting you to keep on watch and just take down all the notes and try to remember the concepts. Protocols means you have to remember is it is nowhere derivation, is nowhere problems or nowhere programs. So you have to remember the concepts, you have to remember and you have to understand the concepts before working into it. So yes, we'll get back into the next tutorial with the continuity of the CAN protocol 3, that is OSN ISO standard.